Welcome, everyone. Today we're diving into a really fascinating internal study from the AI company Anthropic. They actually turned the microscope on their own software engineers, who are, some of the very first AI natives in the workplace, to get at a huge question. What happens when the people building the AI are also its most advanced users? Their experience? Well, it's a sneak peek into the future of work for pretty much all of us.
So the headline number that came out of this study is just staggering. On average, Anthropic's own engineers are reporting a 50% productivity boost from using their own AI model, Claude. Just let that sink in for a second. That's not some small incremental improvement. That is a fundamental shift in what a person can produce. But what does a number like that actually mean day to day?
Well, as you can probably guess, that single number is really just the tip of the iceberg. The real story here is a lot more complex, and frankly, a lot more interesting. This isn't just about doing the same old work faster. The very nature of the work itself is changing, and that comes with some incredible new powers, but also some very real anxieties. Okay, so to get the full picture, we're going to peel back the layers here. First, we'll start with what they call the productivity paradox. Then, we're going to dive right into the numbers from their study. After that, we'll explore the new powers AI is giving engineers, and of course, the new problems that pop up alongside them. We'll also see how the role of the coder is morphing into something more like a coach. And finally, we'll look ahead to our shared AI-assisted future.
All right, so let's dig into this first idea, the productivity paradox. This is really the central tension of this whole story. On one hand, AI is creating this massive surge in output. But on the other hand, it's not as simple as just everything getting easier. It's also introducing new kinds of friction, new challenges, and honestly, new questions about what the work even is anymore.
So to really get our heads around this paradox, we need to look at how Anthropic got their data. Because this wasn't just some quick online poll. No, this was a seriously comprehensive study designed to capture the whole messy, complicated picture. The whole study, which they ran back in August 2023, was built on three main pillars. First, they sent out a survey to 132 of their engineers and researchers to get the big picture quantitative data. Second, they followed that up with 53 really in-depth, one-on-one interviews to get the stories and the feelings behind those numbers. And third, and this is so important, they analyzed 200,000 actual transcripts of their engineers interacting with their AI coding assistant. This let them see what people were actually doing, not just what they said they were doing. So, what is all this AI used for, day in and day out? This chart really shows you the bread and butter. Right at the top, 55% of engineers use it for debugging. That classic, sometimes painful process of hunting down bugs in the code. Coming in next, 42% use it for code understanding. This is like having an instant expert who can explain a super confusing piece of code somebody else wrote 5 years ago. And 37% are using it to help build brand new features. It's pretty clear AI is becoming this constant partner in the core, everyday work of an engineer. And just look at how fast this is all happening. Only 12 months before this study, engineers said they were using AI for about 28% of their work, and they felt about a 20% productivity boost. Now, fast forward just 1 year to the time of the study, and those numbers have absolutely exploded. They're now using AI in almost 60% of their work, and that's where that massive 50% productivity gain comes from. This isn't a slow drip. It's a tidal wave.
Now this chart, this right here is the absolute heart of the productivity paradox. Take a look at that middle column, change in time spent. For all these core tasks, the time engineers are actually spending has only gone down slightly. But then, look at the column on the right, change in output volume. It's seen a large increase pretty much across the board. They're not just working a little bit faster, they are producing dramatically more stuff in about the same amount of time. And the interviews turned up something fascinating. Some engineers said they now spend more time on certain tasks, either because they have to debug the AI's code or because the AI lets them be way more thorough than they ever could have been before.
And this is where the story gets really interesting. This isn't just about making things faster. I mean, sure, 73% of the AI-assisted work is about speeding up existing tasks, but a full 27%, that's more than a quarter, is entirely new work. We're talking about tasks engineers said they just plain wouldn't have done otherwise. Things like building useful little internal tools, running speculative experiments, or finally getting around to fixing those small paper-cut bugs that have been annoying everybody for months. So AI isn't just boosting productivity, it's literally expanding the scope of what's possible to do.
Okay, let's move on and look at how these new superpowers create a whole new class of problems. With great power comes, well, a new set of really complex trade-offs you have to navigate.
So on the one hand, AI is incredibly empowering. It's turning specialists into generalists. Just listen to this engineer. They can now capably work in areas they used to be scared to touch. They're becoming more full stack, which just means they can handle a whole project from the database all the way to what you see on the screen. This breaks down barriers between teams and can make development move way faster. But here's the anxiety that comes with that power. This engineer points to a really deep concern about skills getting rusty, or what's called skill atrophy. See, when you struggle with a hard problem on your own, you're not just fixing one bug. You're building this deep mental map of how the whole system fits together. The study calls this collateral learning. And when the AI can just instantly serve you the answer, you risk missing out on that deeper understanding that is the foundation of real expertise.
And that leads us to this core dilemma, which the study perfectly names the paradox of supervision. Think about it. To use an AI well, you have to be good enough to know when it's making a mistake. You need to have good judgment. But the very skills that give you that judgment are built through the hands-on practice that the AI now lets you skip. It's this tricky feedback loop. The more you lean on the tool, the less capable you might become at actually judging its work.
So with all these new dynamics in play, it's no surprise that the fundamental role of a software engineer is changing. It's shifting away from being a hands-on creator and becoming something more like a manager, a director, or a coach.
This comparison here lays out the evolution so clearly. The old role was all about being in the weeds, writing code line by line. The new role? It's shifting to being more of a manager or an architect. In fact, one engineer estimated that their job has become more than 70% code review, not code writing. The main skill is moving away from creating the code yourself and toward directing, critiquing, and shaping what the AI produces. This whole transformation is also having a huge impact on how people work together. The AI is now the first place you go with a question that you used to take to a senior teammate. And, as this senior engineer points out, it's a real double-edged sword. On one hand, the junior engineers get answers way faster and probably learn more quickly. But on the other, those natural opportunities for mentorship and just human collaboration might start to fade away. So to handle this new world, engineers are kind of naturally developing a strategy for how to delegate work to the AI. They start small, giving the AI low-stakes tasks where it's really easy to do a quick sniff test to see if the answer makes sense. Then, as they start to trust the AI's reliability in certain areas, they'll hand over more complex stuff. But, and this is so crucial, the highest level work, like the core architectural design, the strategic thinking, the things that require human taste, that's all staying firmly in human hands. And that brings us to our final, and maybe most important part of this whole explainer. What does all this mean for the future of software engineering? And, probably for a lot of other jobs too. Because underneath all the excitement and all the incredible productivity gains, there's a deep and very real current of uncertainty. This quote here is stark. It kind of feels like I'm coming to work every day to put myself out of a job. And it was a feeling that was echoed by several engineers in the study. They are keenly aware that these amazing tools they're helping to build could fundamentally change their own careers. So in the end, what you should really take away from all this is the central trade-off. On one side of the scale, you've got these immense gains, radical productivity, learning at hyperspeed, and the ability for teams to take on way more ambitious projects than ever before. But on the other side, you have these very legitimate, deeply felt concerns. The risk of skills fading, a changing relationship with the actual craft of the work, new social dynamics, and a profound uncertainty about what a career in this field is even going to look like in 5 or 10 years.
And that really leaves us with a final, provocative question to chew on. As AI gets better and better at the technical implementation, the how is our most valuable, most human skill, becoming knowing why. Maybe our future isn't about writing the perfect line of code, but about defining the purpose, the strategy, the taste, and the ethics behind it all. In other words, maybe our most important job is simply to know why we're doing it in the first place.